So in the last section here, we're going to talk about comparing linear functions to inverse variation, right? We know that linear functions have what kind of graph? What kind of line is an inverse linear equation? It's straight, right? Who remembers what kind of line an inverse variation is? You remember? Way back, the very first book, when we did inverse and linear together, and we did that the square or rectangle problem. Long time ago. Kind of line.
So like an infinite line.
Yeah, it's an infinite line. It's actually got a little curve to it, remember? You got a little graph here and it curves. It doesn't touch the X or Y axis at all, but it curves. And this goes up and up and up and up and up, but never touches. And this goes out that way and never touches. So straight line versus a curved line, right? And then, of course, the other big difference between the two was the inverse variation has no intercepts, where an linear does. So that's what we're going to be working on in this section here. So our first scenario is Betty's Bakery here. They sell giant cookies for $1 each. All right, this price is not high enough for the bakery to earn a profit anymore. So they got to obviously raise their price, or why make a cookie that you don't make any money on? That doesn't make any sense, right? So Betty must raise the price, but she doesn't want to lose customers by raising the price too high or too quickly. You just go from $1 to I'm gonna charge you $8 a cookie. People are gonna go, see you later. So she considers, and this should be 2 plans, because there's only 2 plans up here. I don't know why there's 3 on here, but she considers the following 2 plans. Plan 1, raise the price by 5 cents each week until the price reaches $1.80. And then plan 2 is raising the price by the same amount each week for 8 weeks, and then the price reaches $1.80 in the 8th week. So those are the 2 plans. So here's your task. We're going to pause this thing here in a minute, let you guys work. All right, you're going to fill in plan 1 and plan 2, the table. Below the table is where they're going to ask you to write an equation for each plan. So plan 1, plan 2, as your group, come up with an equation. And then on the back page, if you flip it over, they want you to graph that. Okay, so we're going to give you about 10 minutes or so to work on this. All right, I want you as a group to come in and fill those things in, and I'm going to have some random groups come up and write their answers in. All right, so I'm going to pause the video here. All right, so we got some answers up here on the board. The tables are good. Okay, plan 2, you ended up going up by 10 cents, right? Because you basically go up 8 weeks from $1 to $1.80. That's 10 cents, right? So you end up with $1.80. Plan 1 takes a lot longer, 16 weeks before you hit that $1.80. All right. So the equation, this equation right here, is for plan 2, and that is correct. They start out at $1. It's a constant rate of change at 10 cents a week. We do got to make a change out of this equation. This is plan 1. Okay. You start out at $1, not $1.80. So this should be either 1 or 1.00. Okay. But your constant rate of change is right. Whether they wrote it this way, it's fine either way. So you could have had it as 0.05x plus 1, or like they have it first, that's fine too. Okay, so that's actually $1. Because we end at $1.80. It's not our starting point. Y-intercept. All right. So when we go to graph this over here, okay, well, if this is our weeks, and I got to fit 16 in here, so I'm just going to go by 2 so it fits. And this is our price. Okay, plan 1, which we'll do with the blue line, right? We went up 10 cents. So at 0, it was at $1. And at 2 weeks, it was $1.10, right? Because it was going up 5 cents every 2 weeks, or 10 cents every 2 weeks. And then 20, right? Because there's other dots in here for every 5. My X is going by 2s. So if I draw my line, I'm going to use my tool here to draw a straight line, because we all know I can't. There we go. Okay. So there's the visual for plan 1. Now plan 2 was going up 10 cents every week, right? So every 2 weeks it was 20 cents, which looks like this. And if we draw that line, starting in the same spot, you can see that it goes a little quicker. So using this visual, I'm going to have you have a short little conversation with question D. Now this is strictly an opinion because there's really no right or wrong answer, but it says, which plan do you think Betty should implement, and give reasons for your choice? So remember, way back in the story, she talked about she needed to up her cost of the cookie because she doesn't make a profit anymore, but she didn't want to do it too fast because she didn't want to lose customers, but her goal was to get to $1.80. So you and your group talk about, is plan 1 a better choice or is plan 2 a better choice, and why? Just give a reason why. There is no wrong answer. This is strictly your opinion. So I want you to have a short little conversation. We'll give you about 3 minutes to talk about it. We'll talk about both plans. Go. All right. So, ladies and gentlemen, so how many people thought plan 1 was the better plan? Nobody? Nobody thought plan 1, nobody in the whole room thought plan 1 was better. Okay, so what was your idea, what was your reasoning for plan 1 being a better plan?
Probably won't lose any customers.
Why?
If it's like raising that price, it's not 10 cents.
Okay, so it increases slower. You have a slower increase in the cost, right? I'll put cost in parentheses. All right. And then Logan said by increasing the cost slower, you may have happy customers. I mean, obviously that's to be determined, but we'll say happy customers. Okay. Yeah, I mean, have you ever had something where you've gone to your favorite place, and the next thing you know, you come back and it's jacked up like 50 cents or something like that? You get pretty mad, don't you? Well, yeah, gas prices. That's a great example. You're like, woohoo, $2 a gallon, then you come back a week later, it's $3.50. You know, what are you talking? So, all right. Shh. All right. So, how many people said plan 2 then was a better plan? All right. What was your reasoning for plan 2? Amra, what was your reasoning for plan 2? What was your reason that plan 2 was better? Okay. So this obviously increases faster, right? And again, it does because the slope is double, right? 0.10 is twice of 0.05. So it obviously increases faster. And she hit it right on the nose. You're going to get a profit quicker, right? Now, again, this is pretty much an opinion question. The only time will tell. I mean, obviously, this is a fake scenario, but her customers obviously would be the judge of which plan was better, right? If she doesn't lose very many or at all, depending on what she implements, then it was a good plan. If she loses a few, then she should have went with the other one. All right, so we're going to take this a step further. This is what we're going to end on for this part here. All right, so Betty suspects that someone is stealing her chocolate chips. I know that's like a felony. Steal chocolate chips. So there are 1 million chocolate chips in a new canister. Betty uses about 40,000 chips each day. How many days should the canister last? So that's what your first task is going to be in your group, is to figure that out. And then you're going to graph that scenario to the graph here and come up with an equation down below. There's only one line here, right? There's only one scenario. There's not 2 lines like we didn't. There's no 2 plans here. Okay? Helpful hint of advice, you may want to do your y-axis, maybe by 100,000s. Going up instead of by ones, because you're talking about really, really, really big numbers. All right? So we're going to pause this again and let you guys work on A, B, and C for our last part for today. Get out together here. So, all right, so what did you come up with for, how many days should the canister last? What did you come up with, Yasmin? 25 days, that's correct. How did you come up with that? What did you do? She did 1 million divided by 40,000, right? Because this is total chips, right? Right here. This is chips per day. So that's to tell you how many days you can get out of the whole batch, and if you divide it, you get 25. Okay? So that's when they're all gone. That's when they're supposed to be all gone. So if we go ahead and graph this, okay, if this side here is number of chips, so obviously we got 0, and then we're going to go up really big here. So we got 100,000, 200,000, and so on, all the way up. All the way up to 1 million, right? Which just happens to be our starting point, right? And then if we want to get the number of weeks in, well, if I got 10 lines, and we know we got at least fit 25 days in here, right? Because this is days. Days. I mean, you go by 2.5, so this was 5, 10, 15, 20. You could have went by 3s, too. It just is going to look a little different, but we know at 25 days how many chips are left. No, not 1 million. 0. Okay? So, if I just play connect the dots, from corner to corner, at 25 days, we're down to 0 chips. At 0 days, we're at 1 million chips. So, what equations are going to make sense for this? What's our constant rate of change? We know our starting point is 1 million chips, right? What's our constant rate of change? 40,000, right? She uses that many chips per day. So what do you think our equation is going to be? This is a linear model, right? It's a straight line. Ethan?
I put G equals 40,000 minus 1 million because it's tracking.
You said D equals?
Oh, yeah, days.
Days isn't the independent variable. So your chips is. So you can have C or Y equals. So what was your constant rate of change is 40,000, right? So what's that number going to be? She uses 40,000 chips a day. Yes. Okay. Now, it can be written like this, or there's another way. Hold on. It can be written like this, where you start with 1 million, and you're taking away 40,000 chips per day. Same thing. Again, if I plug 25 in for X, I end up with 0. And that takes me down to nothing. All right, so this we're going to leave off for the first day. We'll wrap it up tomorrow.